Hi everybody, I've just managed to get this working, which is a MIDI command that is being sent to my phone over Bluetooth LE by this guy, which is the Pi Pico W. This is currently running inside AUM, which is a DAW for iOS, and what I want to show you is this device over here. This is my device, the half-sold solo Bluetooth. So it's picking it up quite nicely. It's actually sending MIDI commands, and I'll try to explain quickly how I've done that. So let's have a look over here. So the environment I'm using is the Pi Pico SDK environment. It is something that's been recently updated. So I think very recently they've updated the Pi Pico SDK. It's now on version 1.5.1, and it's got official support for Bluetooth, which is very cool. I'm using the one-click installer for Windows 10 because I'm on Windows 10. You download this, install it, it creates a little environment for you for Visual Studio Code and for the Pico. And effectively what it does is it creates it opens up your Visual Studio Code in the Pico examples folder. What that looks like is like this inside Visual Studio Code. Now the way I've got this to work is by modifying one of the original example files. I'm using the GATT counter example, and I've modified the original source file and GATT header. Now I don't understand CMake files all that well, so I've been unable to get this thing to work as a standalone folder. So the workaround for now is I'm actually modifying the original example files, and they are in program files. So where your thing is installed, program files, Raspberry Pi, in the BT Stack examples folder, I've actually modified the getCounter.c file and the getCounter.get file. These are all still in your program files folder. Not ideal, excuse me, not ideal, because each time you write to it, it's going to moan about having to need admin privileges. But I got this to work this way. So to get it to work, you basically need to modify these two files, the getCounter.get file, which is like the service descriptors, and the getCounter.c file, which is the actual bit of code that makes it work. There are some other files here. There's the getCounter.h file or header file. This gets generated by the build system. So when you go and you build it, it'll actually create this file for you. You don't need to modify this. You can if you want to do it manually. There's a little bit of a tip at the top here about how to run the Python file to generate this file, and I did this yesterday before I figured out that you actually don't need to do it. It'll actually just get done magically by building it. It's very nifty, but also very obscure how that works, so I don't know, it works. There's some other files in here, also from the program files SDK folder. There's a Bluetooth get.header file for some of the constants we may need to modify. There's a Bluetooth data types header file, which has also got some constants for the advertising bit of side of things. And there's the compile get.python file also in program files that also has a constant write without response that I needed to add. Right, so these are for reference, the Python file, the other header files. Alright, but really you need to focus on the getCounter.c file and the getCounter.get file. So let's start with the get file. This is a like a service descriptor file, and okay, we don't really need the comments over here, we can take that out. I've got 4 services. I've got the gap service, and I've given it a name, BLE MIDI test, for my device name. I have the further device information, which is another kind of service that you can add, and I have a manufacturer name, which is half devices. I've got the model number, and I've got the firmware revision. Alright. I have a battery service. This actually came with the original code, so I haven't modified this. This is still what it was. And then the magic bit is the MIDI service. Now I added this, and there is a very specific UUID, or universally unique ID, 128 bits, that if you search the internet you'll find that for Bluetooth LE MIDI, this is the UUID you need to use. Now, since I don't have a constant map to this, I just plonked it right in here, because you can do that. So that is the service UUID for Bluetooth MIDI LE, and there's a characteristic that goes along with that, that is also this very specific UUID for Bluetooth MIDI LE. And once again, these are the 2 things that you need to use. There's no alternative, it looks like. These are the 2 specific UUIDs. Also on the MIDI characteristic, you need to have read, notify, and write without response. This seems to be the supported flags. And if you don't know what this should be, you can go look at exactly what that is by looking at your compile get.py file to find the relevant correct name for that constant. Alright. So you've got to set up your headers, like your service for services for your little program, and when you compile it, it'll actually generate this H file, header file, for you. Now this header file is going to be put into your build folder. So if you now go to your Pico examples folder, build, and we should have Pico W, Bluetooth, get counter, generated. Right. That is where that file is generated, and it's placed over here. When you build it as well, it'll create the UF2 file, and that'll be also in your build folder, Pico W BT get counter. We'll get back to this. Alright, so let me just save the header file, because I removed the comments. It's going to moan about having to retry as admin, which is annoying, but it works. Okay, then on the C file, you've got to do basically 2 things, actually 3 things. First thing is, the original service that was in here was some other kind of data service, and I can't remember what it was. But you've got to then change the references to that data service to your MIDI service. So what it does in your header file, it creates these constants, ATT service, and another ATT service. So you may need to replace these constants, the other constants that was used in this file, with your specific characteristic. So there's one of them. I think there may be another one over here as well. Right, or 2. So you may need to replace those constants. I think there's three references of those. You need to set up your advertising header. So this is the advertising header data, and we'll get back to this in a moment. What you can do is, there's a SI Labs website that I found, Silicon Labs, that explains very nicely how the advertising header works. And they actually have an example here that uses a 128-bit UUID and explains the lengths and the setup for this, and I've basically taken this and created my own little advertising header, and it seems to work. So we have this guy, which is the flags with a length of 2 bytes. We have the, change this back to what it was, we have the shortened local name, which is half solo, and it's 9 bytes in total, so you've got to give it the length before you start. And then we have the MIDI Bluetooth UUID, for Bluetooth LE. So once again, the AD type is this complete list of 128-bit service class UUIDs. I got this from the Bluetooth data types header file, closest corresponding match. And then you have the actual service UUID written in backwards format. What does that mean? So the MIDI BLE service UUID looks like that. It's 03B8, etc. If I look at my GAT file, it's the same as this 03B8 over here. It's the same UUID. Now, if you take this file, this byte collection of bytes, and you write it in backwards fashion, you actually start with 03B8, and from the backward side you have 03B8, and then you have 0E5A, and then here we have 0E5A. So it's literally written in backwards format. Now you can do that manually, or you can just go to your header file, which has been auto-generated, remember, and it does the same thing. It actually writes it over here. So there's the primary service 03B8, 03B8, etc. It also has some additional stuff in the front here. I'm not sure what that is, but you can basically copy everything up to about there, 00C7, because this thing ends with 00C7, and you copy that and you use that in your advertising header. Now this advertising header is 31 bytes maximum apparently, although I think there is an extended version of this, but I didn't want to fiddle with that. 31 bytes is enough for me to get the flags, my local name, and the MIDI BLE service UUID in there. And this is important because otherwise devices such as your iOS stuff don't know that your device can provide MIDI BLE. So this is fairly important to get the advertising header right. Next up we have the MIDI data. So there is a little beat function that gets called on a regular basis, I think every half second or something like that, and I just modified the existing one to send a MIDI packet. Instead of what they had was this, they had this BT stack counter, a little string in there. So I'm not using that, I'm using a collection of bytes or a little data packet to send a MIDI note on when my counter is an even number, and a MIDI note off when the counter is an uneven number. Now the MIDI packets, once again, if you look at the internet, there's a SparkFun MIDI BLE tutorial. It explains how the MIDI packet works. There's a little timestamp, MIDI status, MIDI data 1 and MIDI data 2. So that would be, for example, your note on with a channel 0. This will be the actual note value. the node number and then node value. Fairly simple. This is 5 bytes, and then you can send packets of these MIDIs. So I think that's really it. So in your C file, you need to get your advertising header right. In your C file, also your heartbeat, you can modify that to send your MIDI packets. And just make sure that you are referencing the correct characteristic. So you may need to find the you'd replace the original characteristic name with the new characteristic name, which is this UUID version. Okay, then we're going to do a compile or a build. So we click the little build button. Actually, I need to probably save this and save this as admin once again because it's in program files. So frameworks are great except when you don't understand them. Anyway, let's build this. And then the build will generate a UF2 file, which we can then just drop into the Raspberry Pi Pico once it gets available. Okay, so we've got exit code 0, so the build was successful. And that's a timestamp 1309, that's the time now, so that's the most current version. Alright, let's just switch to the camera. So now on the Pi Pico, you can switch to boot cell mode by unplugging it, holding the little button down, plugging it back in. Okay, so now it becomes available as a little drive on your machine. Here we go, RPI Raspberry Pi RP2. Okay, and what we're going to do is we're going to send this to the D drive. But before I do that, let me show you a few other things. In fact, you couldn't see that, could you? Because I'm in the wrong place. Okay, so let me try that again. So this is the D drive that was now created when I plugged the Raspberry Pi, unplugged and replugged it in. This is the UF2 file that it was generated, and we'll send that across shortly. Other things that are useful are these guys. This is the Critic BLE analyzer. It's something I downloaded yesterday or the day before to capture Bluetooth packets. And there's another one as well. There's called the BLE Bluetooth LE Explorer, and it does the same thing. They both give slightly different views, so I'm ended up using both. So let's just start with the where's my OBS? Here we go. We're going to start with this guy. This is the iRig Blue board. I'm borrowing from John. Thanks, John. So I'm going to activate this, and then we'll see what happens on the analyzer. Alright, so let's just switch this on. Okay, now you'll see we've got the iRig Blue board available, and it's got some things over here, device info, etc, etc. I'm going to do the same thing and now actually copy the UF2 file to the Pi Pico. That will update the firmware, and once the updated firmware is in, we should see it active as a Bluetooth device, and there we go. So now if we look at the device attributes, we're still on the blue board. We've got appearance, flags, complete local name, 128-bit service class UUIDs, and some unknown data type. On the Hof Solar we've got flags, shortened local name, and our 128-bit class UUIDs. So you'll see these three are exactly the same thing as what we have in our advertised header. There we go. Flags, local name, and UUID. flags, local name, and UUID. If you go into the UUID, that is our Bluetooth LE MIDI UUID. Right, that's important. If I go look at the Bluetooth, the iRig Blue Board, it's got some additional things. Appearance, I don't know if that's important. It's got the same flags. It's got a complete local name. I don't know how they do this. If they have an extended advertising header, doesn't make too big a difference. And they've got the same Bluetooth MIDI UUID. So after a bit of work, you'll start becoming familiar with this number over here. Okay, so that is the Bluetooth MIDI LE service UUID. So that is a good match, and that's great to have the iRig Blue Board available to kind of see what they were doing and try and match that. Now we can have also a look at the Bluetooth LE Explorer. It's also quite cool to see things. It just got a bit of caching sometimes, so it still has the old name, so it might take a minute for this to refresh. Come on. We are waiting. Okay, there we go. Alright, so here you see this is our list of services. This is not the same as advertising. This actually matches the GAT file. So if we look at our GAT file, these 4 services, the GAP service, the device information, battery service, MIDI service, that is exactly what we are seeing over here with their values. BLE MIDI test, off device solo, etc., the battery, and this is our Bluetooth MIDI LE characteristic and service. You can click on this and then see some more stuff. This wasn't that practical. I'll show you on the iOS side a better way of doing this, but you can actually go and interrogate some values with this. If I look at my Blue Board, you'll see the same thing. We've got generic access, generic attribute, device information. It's actually got some additional things here, firmware and PID. I don't think that's necessary. Battery, and once again the Bluetooth MIDI LE service descriptor and characteristic. Okay, so 2 nice tools to have at your disposal: Bluetooth LE Explorer and this acrylic BLE Analyzer. I'm sure there are others, but these have been working for me. Now if we look at the iOS side of things, I'm just going to stop this because I think you need to actually disconnect. So I'm going to have to disconnect things a little bit. There we go. Let's just go to this guy. So I'm just going to unplug this. That's probably the easiest way to disconnect it. And the same thing on the Blue Board. It's still okay. It's not connected. It's flashing. Right, now on the iOS side, what we're going to be doing is there's 2 tools. There's a Blue C and a thing called MIDI MTTR. Now Blue C is quite cool because it's kind of like a let's find a better way of putting this. Okay, you can't see much, but I'm doing a scan, and I'll see if I can get this to work. Okay, so there is so much glare. Sorry about that. There's the half solo and the iRig Blue Board, and you can actually go into the iRig Blue Board, connect, and it'll bring back a list of services. You'll see at the bottom here, there's services. The top line, that is once again our UUID for Bluetooth LE. You click on that, you can subscribe, and what will happen is, Let's find a good spot for this. Okay, not great, but you can see that is a number under the, oh my goodness. Okay, there's a number there under subscribe, 8080BWD something. That number changes when I press a button on the iRig Blue board. Right, so you can't see it, but I'm actually pressing this button over here. See if I can do it at the same time. Let's see. There we go. So that is actually sending a MIDI command, and with this, once you subscribe, you can actually see the change. So let's go back now to the half solo. So I'm going to connect to that guy. So now this is the the half solo, and guess what? It's got the same 3 services, including the MIDI BLE one. If I look at that and I subscribe, come on, you'll see every half a second that code changes to, it's not great, let's see, 8080 or 8009. Right, so that, once you can see that, that means your MIDI packets are in fact being synced, because that is exactly the MIDI packets that we are sending to with a little heartbeat counter. There we go. So those are the 2 packets that are being sent and received. And then once again, if you are seeing that, another way to check it is if you go to MIDI MTTR, which is this guy here. I apologize, I've only got so many USB ports and they're all being used, so I'm using the laptop camera. So MIDI MTTR will actually pick up Bluetooth LE devices, and you can actually connect to it, and as soon as you connect, you'll see a little flash each time you send the packet. So once again, just another way to verify that things are in fact working. And then once you get to that point, then you can fire up your DAW and connect it to your MIDI device, and you can start playing, which is what I'm going to do now. It's going to hook up some buttons to this guy and have my own custom MIDI Bluetooth controller. So I think that's been a long video. I apologize if it's a bit wordy, but hope it's helping somebody out there. Alright guys, cheerio.